Today we will discuss about another loop control structure in C programming, that is nested for statement. In the previous class we discussed for statement and how to use in C programming. Today we will discuss nested for statement or nested for loop. The statement block of a for loop lies completely inside the block of another for loop. One inside another, nest. It's called nesting. So this is referred as nested for loop or nested for statement. Any number of for statements can be nested. Its structure, a form is shown here. For I is equal to 1, I is smaller than or equal to 3, I plus plus. This is one for statement, and inside this for statement another for statement is nested. For j is equal to 1, j smaller than or equal to 5, j plus plus. This loop, inner loop, is being nested in one for loop, outer loop. This is inner loop, this is outer loop. Here we are using I for iterations, here we are using j for iterations. So for loop here, this is the outer body, outer loop, and this is for loop here shown in blue color. This is inner loop. One loop, inner loop inside outer loop. For loop, inner loop ends here and the outer loop ends here. When the statement is executed, the computer assigns I is equal to 1 and the inner loop is executed 5 times for j values from 1 to 5 in steps of 1. J, it is initialized at 1 and j smaller than or equal to 5, j plus plus, it's going to be incremented. First it will be 1, the next iteration it will become 2, next it will become 3, 4, 5. Like this 5 iterations it is going to be operated. Now for each I value, I starting from 1 being incremented by 1, as long as I value is smaller than or equal to 3 iterations. I is equal to 1, I is equal to 2, I is equal to 3. I is incremented by 1 and the inner loop is executed 5 times for j values from 1 to 5. Then I becomes 3 and the inner loop is executed 5 times. So totally 5 times inner loop and 3 times outer loop. Totally 15 times this program is going to be executed. This is nested for loop. And also we will discuss about the other control structures. While statement. A while loop is used to execute and repeat a block of statements depending on a condition. It has the following form. While, this is the condition here, this can be either true or false. While this condition is true, within braces the condition is being written, a relational or logical expression. As long as this condition is true, this block of statements to be executed. Example is shown here. I is equal to 1. While I is smaller than or equal to 10, this block of statements to be executed. S is equal to S plus I, P is equal to P into I is getting incremented and it comes out of this loop and back to this one to check the condition. While I is smaller than or equal to 10, this block of statements to be executed. This is while loop, while statement. One thing to note is that there must be a statement written inside the statement block to change the value of the condition, otherwise the loop will be infinity. This is shown here. This I value to be incremented inside this block of statements. In case if this one is not placed here, it will do the uh, performing of this block of statements infinite number of times. So we have to take care that incrementing should be included within this block of statements. And a small variation of the while statement is do while statement. A do while statement is also used to execute and repeat a block of statements depending on a condition. It has the following form: do this block of statements while the condition is here. In while statement, the condition was placed before the block of statements. Here in do while, first the block of statement is coming and the condition is placed at the end of the block, after the block of statements. While condition, where condition is a relational or logical expression. Example is shown here. I is equal to 1, we have initialized I is equal to 1, declared. Do what to do? This block of statements. S is equal to S plus I, P is equal to P into I plus plus incremented, while I is smaller than or equal to 10. So as long as I is smaller than or equal to 10 means as long as this is true, this block of statements to be executed repeatedly. And when I is not smaller than or not equal to 10, this comes out of this loop and the program ends there. So these are the statements or the loops that we discussed today: for loop, while loop, and do while loop. So we'll solve some programs today to understand more about these statements. There are programs at the end of this notes being given to you. Nested for statement. Yes, here there is one program. For nested for, yes, here it is, there is a program. A nested for loop can be written to generate various combinations of x and y. Problem number 12, and here there is another program. Yes, this is program number 11. Write a C program to find the sum of the following series: s is equal to 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4, continues like this up to 1 plus 2 plus 3 plus n. So a nested for loop can be used in such cases to find the sum of the series. The inner loop is used to find the term values. This inner loop is used to find the term values, that is 1, 1 plus 2, 3 plus 1 plus 2 plus 3, 5, and so on. These are added in the outer loop to get the sum of the series. See how it is done. Program to find sum of series include stdio.h, include conio.h. Main program starts here. We are declaring the variables here: integer I, j, n, s, term, CLR, SCR. Clear the screen, printf, enter value to n. So the input that is the value of n is taken through the keyboard. Scanf %d ampersand n. S is equal to 0. So we start with the value of s, which is equal to 0. Outer loop is shown here. Outer loop iterational variable is I is equal to 1, I smaller than or equal to n, I plus plus incremented. So inner loop to find this is the outer loop, and inner loop to be placed, term is equal to 0 for j is equal to 1, j as long as it is smaller than or equal to I, j plus plus, term is equal to term plus j, and this is ending here. S is equal to s plus term. Printf sum of the series s is equal to %d s gets h. This can also be understood through that is yes. The programs list is here. That is sum of series. This is the program. This program to be we have to take a notepad, series, go to the turbo C, there open SE. This is the program. There are some corrections to be done. Because we have copied from yes here on. Yes, it is to be saved. Series execution, that program run. Enter value to n, the last number 5. Let us put it as 5. Sum of the series will be s is equal to 35. In case it is 3, 1 plus 2 plus 3. sum of the series is equal to 1, next is 1 plus 2, next is 1 plus 2 plus 3. So this will be equal to 10. Yes, it's right. So like this we can solve this program. Like for a 4, sum of the series will be equal to 20. So like this we can solve the program. This is one example, and check whether the program is prime or not, whether a given to check whether a given number is prime or not. That can be done here. Prime or not. Divisible by 7. Okay, divisible by 7. This program we shall look at. A C program, right? A C program to find the sum of all odd integers between 1 and n. So this program is here. Program to find sum of odd integers between 1 and n. Include stdio.h, include conio.h. Main program start here. Integer s, I and n variables. Clear the screen. Printf, enter value to n. Scanf %d ampersand n. S is equated to 0, I is equated to 1. While I is smaller than or equal to n, s is equal to s plus I is equal to I plus 2. So here what we have done is I is equated to 1. I is inside the loop, while loop, I is made equal to I is equal to I plus 2, means if it is 1 here, next then in the first iteration, after the first iteration it will become 3, I plus 2, 1 plus 2, 3. In the next iteration it will become 3 plus 2, 5. Like this, only odd numbers are going to be added, only odd numbers are going to be considered. So start, read n, I is equated to 1, while I is smaller than or equal to n, s is equal to s plus I and I is equal to I plus 2. So only odd integer numbers are going to be taken into consideration, and it is going to find the sum of all the odd integers between 1 and n. So this is the program. Let us solve this program. Program to find sum of odd integers between 1 and n. So the same program is written in C compiler editor. So now I am going to run this program. Run. Yes. N. Find the sum of all odd integers between 1 and n. For example, if it is 5, 1 plus 3 plus 5. Let us give 5, and what is the result? Let us check. Yes, 1 plus 3 plus 5, it will be equal to 9. So the result is correct. Let us check once again. In case the value is 8, it will be, what will be the result? 1 plus 3 plus 5 plus 7. 1 plus 3 plus 5, 9 plus 16, it will be 16. The result is 16, right? So like this we can get the result from this program. This is example of using while loop. And now we'll look at another program. Print 50 positive integers divisible by 7. 50 positive integers divisible by 7. Program to print first 50 positive integers which are divisible by 7. So this is using for loop I is equal to 1, I is smaller than or equal to 50, I plus plus, n is equated to 7. Before this for loop, printf %d ampersand printf %8d n, the value of n to be printed. N is made equal to n plus 7, so that only positive integers divisible by 7 are taken into count, n plus 7. So if you run this program, yes, first 50 positive integers which are divisible by 7, or we can change the program here in case you need only first 10 integers, just only 10 integers. If you want to find, run only 10 integers. So like this we can change the program and quickly get the results also changed. The program for this flowchart for this program is shown here. Write a program to generate first 50 positive integers that are divisible by 7. A for loop can be used to print 50 integers, and integer n is used to generate numbers from 7 in steps of 7. So program to print first 50 positive integers which are divisible by 7. Include stdio.h, include conion.h, main program start here, integer n and I, two variables, clear the screen, print of integer divisible by 7. So this is on a new line, it is printed n is equal to 7. For I n we have initialized the value of n equated to 7. For I iterations, I is equal to 1 initialized with value of 1, and as long as I is smaller than or equal to 50, I plus plus, go on incrementing I value. Printf %n is equal to n plus 7. So to generate numbers from 7 in steps of 7, a program to generate the first 50 positive integers that are divisible by 7. So if you go on adding 7 to 7, you will be getting the numbers which are divisible by 7. That is the concept here. Start n is equated to 7. For I is equal to 1 to 50 steps. Print n. N is added with one more 7 to get the number divisible by 7 back, as long as I is smaller than or equal to 50. I is smaller than or equal to 50. As long as this is true, this loop is going to be repeated and stops here. The result will be integers divisible by 7 will be 7, 14, 21, 28, 35 up to 350. That is what we have done in this. I shall give once again the value of 350 and check that divisible by 7, first 50 positive integers, they are already printed, yes. Okay, n and I, n is equal to 7, I is equal to 50 we made. Run this program. Yes, this is the result of this. Okay. So today we have understood nested for loop, while loop and do while loop, and we have seen some programs making use of these statements, that is nested for loop, while loop and do while loop. In the next class we will solve some more programs to understand in depth about these loop control statements or loop control structures in C program. Thank you.